Hello there, I am Dr. Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. Thank you for joining me once again in another round of lecture and solving problems with respect to probability. We are still going to continue with our discussion on looking at the addition rule of probability. In an earlier video, we had gone through looking at addition rule 1, where we have mutually exclusive events. Mutually exclusive events are events that cannot happen at the same time, in that you are just one chance and one choice of choosing this or that. How you solve that is to add the probabilities of both events. That's what we've looked at in an earlier video. In today's session, we are going to look at the rule 2 of the addition rule, and this is when the events are not mutually exclusive. Not mutually exclusive. There are two events, but there's a commonality of the two events. We have two events, but there's a commonality of the two events. That's when the events are not mutually exclusive. And then you still have a chance of choosing one, but you find out that there's a commonality between the two events. Let's look at what we have to look at. So addition rule 2, addition rule 2, that is not mutually exclusive events. Okay, so not mutually exclusive events. In this case, when the events are not mutually exclusive, we have probability of choosing A or B will be probability of A plus probability of B minus probability of A and B. So that's what we solve this problem. So we'll find the probability of A, we'll be given that, then we have to deduct probability of the commonality that happens between them. Let's take an example. We're told that a die is cast. A die is cast. What is the probability of getting an odd number or less than 5 or less than 5? So that's what we ask. Remember, it is one die that's cast, and what's the probability of getting an odd number or a number less than 5? So first of all, we know that the sample space we have is what? Is 6. Sample space is 1, 2, 3, 4, 5, or 6. So that we have 6 sample space. Now, the probability of an odd number is what? The probability of having an odd number. How many odd numbers do we have? We have 1, 3, and 5. So that we have either 1 or 3 or 5. Remember, probability of odd could be any of these. So being that it is any of, it becomes or. And when you have or, what do? You add. So the probability of 1 or 3 or 5 will be 3 options over 6. How did we get 3 over 6? This is 1 over 6, 1 over 6, and 1 over 6. So if you add this, you have 3 over 6. Now, the probability also of getting less than 5, what options do we have? This is 5, and less than 5 gives us 1 or 2 or 3 or 4. And this gives us what? 4 all over 6. So we have 4 all over 6. Now, the probability of being an odd number and less than 5, probability of being odd and less than 5, that's what we pick up. Remember, we're following this rule. We'll find the probability of A, probability of B, minus the probability of both. So the probability of being odd and the probability of less gives us how many options? Now, less than 5 and odd. What are we left with? Less than 5 and odd. We're left with 1 and 3. 1 and 3 gives us what? 2. So it's either 1 or it's 3. So that gives us what? 2 all over 6. So that means that to get the probability of odd or less than 5, will be 3 all over 6 plus 4 all over 6 minus 2 all over 6. I trust you're following. From this, we can find the LCM. We know that the LCM is 6, and this becomes 6 here. This becomes 3 plus 4 minus 2. This becomes what? 3 plus 4 is 7. 7 minus 2 is 5 all over 6. So this is the answer to this question. When we have a case of having events that are not mutually exclusive, in the sense that even though we have an operation of or, but there's a commonality between the events. Let's look at another question very quickly in this session. We have in a class, let me move to this side of the board. In a class, there are 40 students. 40 students in a class, of which we have 22 boys, and then we have 18 girls in that class. 22 boys and 18 girls in that class. And out of this, we have 9 boys. 9 boys scored A in a test. And then we have 10 girls scoring A in that same test. So 9 boys of the 22 scoring A and 10 girls of the 18 girls scoring A in the test. So the question is, what is the probability of selecting a student at random? What's the probability of selecting a boy, or he scored A, or he scored A? So what's the probability of doing that? So we have 2 events here, but then there's a commonality of the event. Now, it's going to be probability of choosing a boy in that class will be 22 all over 40. That's probability of having a boy. Now, probability of scoring A, probability of scoring A will be, probability of scoring A will be that a boy scored A, probability that is a boy, and the probability that is scored, probability that is scored A, you have all the boys that all the students that scored A. Probability of scoring A in that class is 9 plus 10. That means we have 19 students scoring what? A. Now, the probability of a boy who scored A is going to be 9 over 40. 9 over 40. So how do we now solve this problem? So the probability of having a boy or is scored A will now be 22 all over 40 plus all the students that scored A, 19 all over 40, minus the boy that scored A, minus the commonality of the two of them, minus 9 all over 40. That is the boy that scored what? 40. So 9 all over 40. If we find the LCM of this, we're going to have 22 on this side plus 19 minus 9. 22 plus 19 minus 9. 22 plus 19 will give us 41. 41 minus 9 will give us 32. So 32 all over 40. Can we reduce it further? Yes, by 8. If we have 8 on this side, it will give us 4. If we have 8 on this side, it will give us 5. So we have 4 all over 5. So the answer to this question is 4 over 5. The probability of picking a boy, of selecting a boy or he scored A, will be this solution. Please go through this again as we'll look at one other video on looking at cases where the events are not mutually exclusive. Thank you very much.